This is City Logistics, a simulation game developed by InterMarium for Wrocław University of Economics and Business. It is made in FlexSim and features a 1:1 scaled model of the central part of the Polish city Wrocław. The lecturers of this university use the game to teach some of the concepts related to the topic of transportation logistics. And even though we are looking at the panorama of Wrocław, these principles are going to be universal, and so this game could be set up in virtually any city. The goal of this game is to deliver packages to clients that are generated in the central part of the city as denoted by the red border. Each of these purple flags represents one client awaiting a delivery. The way we can achieve it is by placing these transportation micro hubs. We are free to decide where and how we place them, and also how many vehicle types we assign to it. We have a choice between cargo bikes, electric vehicles, and combustion cars. Each of these vehicles will have different financial and environmental performance metrics. The way in which they operate is that at the beginning of the day, the couriers arrive at the hub to pick up the parcels that they need to deliver on that day. Then they start driving towards the delivery points within their region, which are now marked with red arrows. Whenever a delivery is made, the flag disappears. After a whole day of work, the couriers come back to the hub and the turn ends. When you take a look, we'll be able to see that the range of our hub is pretty limited. Let's increase it and see what happens. We advance the turn, and this time we can see that we managed to catch more orders, more customers within our area. If we speed up the simulation though, we will see that we didn't really manage to satisfy all these orders within the turn. The reason is that simply we have too few delivery drivers. So if we increase that number and rerun this turn, we will see that indeed all of these orders have been satisfied. So let's go a step further and see what happens then. This time we managed to seemingly clear the whole area, but if we take a closer look, there is a number of orders at the very edge of it that we accepted but never made the delivery to. You might think that it's because we have too few cars, but the reason will become evident if we switch our view to this map. It shows us all the places that are accessible using a combustion car. We can clearly see that the city authorities have banned combustion cars from entering the central area, and this is why we didn't manage to reach these clients. Luckily, if we take a look at a similar map for electric vehicles, we will see that there is no movement restrictions for this vehicle type. So let's give it a try. Let's replace all of the combustion engine cars that we have with electric ones and see whether that changes the situation. That was it. This is how we managed to clear the whole range here. So what's next? Maybe we would like to expand and set up a new micro hub. It's as easy as just dragging and dropping the icon into the 3D view, adjusting its position, and choosing its operating parameters. That way, we can keep expanding our company to eventually meet the goal of satisfying all the customers within the city. If we are more data-driven, we might want to have a go at crunching the numbers. Luckily, since this is a numerical simulation, there is plenty of information gathered in form of graphs and tables. What this information could be used for is, for example, we could collect all the information about the financial cost of running our micro hubs to drive the growth strategy of our company. Does it make sense to set up a new hub? Or maybe we just should increase the range of an existing one and buy additional vehicles. On the other hand, we could switch our perspective to an environmental one. The game collects information about the CO2 emissions of each of our vehicles. That way, we could switch perspective from trying to maximize the financial profit to minimizing the effect on the environment, thus using some of the principles of the triple bottom line accounting. Seeing how these two objectives, that is, minimizing the costs and at the same time minimizing CO2 emissions, cannot be met at the same time, we could introduce, for example, the tool of Pareto efficiency in trying to analyze a problem like this. This is just one example of simulation games that can be made in FlexSim. Other games that we made at InterMarium tackle the processes ranging from running the new hire interviewing process at an HR department, through agricultural topics of growing crops and responding to various pests and weather conditions, to managing everyday operation of a trash sorting and utilizing facility.